Welcome. Today we're diving into the Mann Whitney U Test, a powerful statistical tool used to compare differences between two independent groups. Unlike traditional tests that require data to follow a normal distribution, the Mann Whitney U Test is nonparametric, making it incredibly versatile for real-world data. Whether you're analyzing survey results, medical trials, or business performance, this test helps you determine if one group tends to have higher or lower values than another. Let's explore how this test works, when to use it, and why it's a favorite among researchers and analysts. Before we go further, let's clarify what nonparametric means. In statistics, nonparametric tests don't assume your data follows a specific distribution like the bell-shaped normal curve. This is especially useful when your data is skewed, has outliers, or is measured on an ordinal scale. The Mann Whitney U test fits perfectly here, as it compares the ranks of values rather than the values themselves. This flexibility makes it a go-to method when standard tests like the t-test aren't suitable. Mann Whitney U test is designed for independent groups. But what does that mean? Independent groups are groups where the individuals in one group are completely separate from those in the other. For example, comparing test scores between two different classrooms or measuring recovery times for patients using two different treatments. There's no overlap or pairing between the groups, which is crucial for the test's validity. But when should you use the Mann Whitney U test? It's ideal when you want to compare two groups but your data doesn't meet the assumptions required for a t-test, such as normality or equal variances. It's also perfect for ordinal data like survey responses ranked from strongly agree to strongly disagree. If your sample sizes are small or your data is not interval or ratio, this test is a reliable choice. Mann Whitney U test works by ranking all the values from both groups together. Each value gets a rank and then the ranks are summed for each group. The test then calculates a U statistic, which tells us whether the ranks in one group tend to be higher or lower than those in the other. This approach makes the test robust to outliers and non-normal data, focusing on the order of values rather than their exact numbers. To start, you combine all the data from both groups into a single list. This step is essential because the test compares the overall distribution of values, not just the means. By pooling the data, you set the stage for ranking and further analysis. Next, assign ranks to all the values in your combined list. The smallest value gets rank 1, the next smallest gets rank 2, and so on. If there are ties, meaning two or more values are the same, you assign them the average of the ranks they would have received. This ranking process is at the heart of the Mann Whitney U test. Once all values are ranked, sum the ranks for each group separately. This gives you two totals, one for each group. These sums are used to calculate the U statistic, which is the core measure of the Mann Whitney U test. The group with the higher sum of ranks may indicate a tendency for higher values. I'll calculate the U statistic for each group using the formula. U equals n1 asterisk n2 plus n1 asterisk n1 plus 1 slash 2 r1, where n1 is the size of group 1 and r1 is the sum of ranks for group 1. Do the same for group 2. The smaller U value is used to determine significance. This calculation helps you see if the groups differ more than would be expected by chance. Finally, compare the calculated U value to a critical value from statistical tables, or use software to find the p-value. If the U value is smaller than the critical value, or if the p-value is less than your significance level, like 0.05, you can conclude there's a significant difference between the groups. Otherwise, there's no evidence of a difference. Let's look at a practical example. Imagine you want to compare customer satisfaction scores between two stores. The scores are ranked from 1 to 5. Since the data is ordinal and may not be normally distributed, the Mann Whitney U test is perfect. You'd follow the steps we just discussed to see if one store consistently receives higher satisfaction rankings. You might wonder, why not just use a t-test? The answer lies in the data. The t-test requires normal distribution and interval or ratio data. If your data is ordinal or not normally distributed, results from a t-test could be misleading. The Mann Whitney U test avoids these pitfalls, making it a safer choice for many real-world datasets. Every statistical test has assumptions, and the Mann Whitney U test is no exception. The main assumptions are that the two groups are independent, the data is at least ordinal, and the distributions of the two groups have the same shape. If these assumptions are met, the test results are reliable and meaningful. The Mann Whitney U test offers several advantages. It's robust to outliers, doesn't require normality, and works well with small sample sizes. It's also easy to use with ranked or ordinal data. These strengths make it a popular choice for researchers in many fields, from psychology to business analytics. Despite its strengths, the Mann Whitney U test has limitations. It can't be used for paired or matched samples, and it assumes the distributions have the same shape. If the shapes differ, the test may not accurately reflect differences in central tendency. Also, it doesn't provide information about the size of the difference, only whether a difference exists. In reporting, Mann Whitney U test results include the U statistic, the p-value, and a brief interpretation. For example, a Mann Whitney U test showed a significant difference between groups, U equals 15, p equals 0.03. This format helps readers understand your findings and the strength of the evidence. Many statistical software packages can perform the Mann Whitney U test, including SPSS, R, Python, and Excel. These tools automate the calculations, making it easy to apply the test to your data. Just input your groups and the software will handle the rest, providing U values and P values instantly. Visualizing your results can make them easier to understand. Box plots or rank plots are great for showing differences between groups. These visuals highlight the spread and central tendency of your data, making it clear if one group tends to have higher values than the other. The Mann Whitney U test is widely used in fields like medicine, psychology, business, and social sciences. It's perfect for comparing treatment effects, survey responses, or performance metrics when data isn't normally distributed. Its flexibility makes it a staple in many research toolkits. While the Mann Whitney U test doesn't directly compare medians, it's often interpreted as a test of median differences. If one group's values are generally higher, the test will reflect that. However, remember that it's actually comparing the ranks, not the medians themselves. Ties occur when two or more values are the same. The Mann Whitney U test handles ties by assigning the average rank to tied values. This ensures the test remains fair and accurate, even when your data isn't perfectly unique. The Mann Whitney U test works well with small sample sizes, but larger samples provide more reliable results. With very small samples, the test may lack power to detect differences. Always consider your sample size when interpreting results. While the Mann Whitney U test tells you if a difference exists, it doesn't measure how big that difference is. For effect size, you can calculate statistics like R or the common language effect size. These give more context to your findings. If your data is paired or matched, consider using the Wilcoxon-signed rank test instead. For more than two groups, the Kruskal-Wallis test is appropriate. Choosing the right test ensures your analysis is accurate and meaningful. Imagine a clinical trial comparing recovery times for two treatments. The data isn't normally distributed, so the Mann Whitney U test is used. After ranking and calculating, the results show a significant difference, helping doctors choose the better treatment. To recap, the Mann Whitney U test involves combining data, ranking values, summing ranks, calculating the U statistic, and interpreting the results. Each step is straightforward, making the test accessible even for beginners. A common mistake is using the Mann Whitney U test for paired data or when the groups aren't independent. Another is misinterpreting the results as comparing means rather than ranks. Always check your data and assumptions before running the test. If your results aren't significant, it doesn't mean the groups are identical, just that there's no strong evidence of a difference. Consider your sample size, data quality, and whether the test was appropriate for your data. To deepen your understanding, explore textbooks or online resources on nonparametric statistics. Practice with real datasets to see how the Mann Whitney U test works in action. The more you use it, the more confident you'll become in your analysis. Mann Whitney U test is a valuable tool for comparing two independent groups, especially when your data doesn't fit the assumptions of parametric tests. Its flexibility and robustness make it a favorite in many fields. Remember the steps, check your assumptions, and you'll be ready to analyze your data with confidence.